reticulocyte count in the body. So remember, reticulocyte count is 0.5 to 2% if you're dealing with an adult. But if you're dealing with a newborn child and you have umbilical cord blood sample in front of you, you have an umbilical cord blood, then children have more cells, of course. It is 2 to 6%, which is the normal value. Repeating, 0.5 to 2 and then 2 to 6. 0.5 to 2 is in an adult and 2 to 6% is going to be in a child. That is the reticulocyte count. And please remember, what is the staining? The best stain that you have, it is going to be new methylene blue. What kind of a staining methodology is it? It is a supravital stain. Because now they will be asking you the next question, and that is, what is a formula? Very rarely have I taught you mathematics. Today, in this chapter, I will teach you two mathematical equations. The first one is in front of you. They ask you, what is CRC? What is corrected retic count? So you will say, I already know retic count, ma'am. What is this corrected retic count? Corrected retic count ka formula you have to know. After that, the examiner will make you do some mathematics. So corrected retic count, you will pick up the whatever retic count is given to you, multiply that by the hemoglobin of the patient divided by hemoglobin of a normal person. Now, we are all medicos, and medicos by definition have horrible maths. At least I have horrible maths. So I will take a denominator which I can use very conveniently, round off, matlab normal hemoglobin, let me consider as 15. Everyone has a different normal hemoglobin, but I'll consider a rounded off value. So now, first you have to learn this. Retic into hemoglobin upon hemoglobin. There's another formula. The same retic, instead of hemoglobin upon hemoglobin, they use hematocrit of the patient divided by hematocrit of a normal person. They could, whatever you will be using, it is patient upon normal. Patient upon normal. So retic into patient upon normal. So let me give you an example. They will give you a chemical, or they'll give you a numerical formula saying there is a patient whose reticulocyte count has come out to be a 6%. Is it normal? Adult hai 6%? Nahi. What is the normal retic count? 0.5 to 2%. So retic count is more. Okay. Then they say the patient's hemoglobin is 5 gram. Is this normal? No, less than 7 gram. So it's severe anemia. This is severe anemia ka case, right? Definitely anemia. So they will say, for this anemia, can you calculate the corrected retic count? That's the simple question that they'll give you. What will you have to do? You will have to do a simple mathematics. I know corrected retic count is number one, reticulocyte count kitna hai? 6%, multiplied by hemoglobin of the patient kitna hai? 5 grams, so multiplied by 5, that makes it a 30, and divided by normal. That's why I said normal rakho 15. So what is the corrected retic count going to be? Your answer will be 2%. So maths is not going to be tough. Only learning the formula is tough. But over here they gave me hemoglobin, so I use this formula. What if they would have given me hematocrit? Do you know what is the relation between hemoglobin and hematocrit? If you just tend to multiply hemoglobin by 3, remember this. If you multiply hemoglobin by 3, you will get the hematocrit. So tell me a quick answer. If the normal hemoglobin I take is 15, what do you think the normal hematocrit of a person is? The normal hematocrit of a person is 45. You look at anyone's blood test report, you will see hemoglobin multiplied by 3 will give you hematocrit. And all these I'm going to tell you gradually. We are going to study all these different formulae in exactly 5 minutes, but I hope you've understood. Corrected retic count is retic count multiplied by hemoglobin upon hemoglobin, or hematocrit upon hematocrit. That is CRC, but the story doesn't end here. After calculating the CRC, you next calculate RPI. What is RPI? Reticulocyte production index. What am I trying to find out? Itne time se this round story that I'm telling you, I am basically trying to find out, is my bone marrow doing work or not? You will say, ma'am, if you want to find out, reticulocyte is where? Is it in the bone marrow or is it in the blood? Reticulocyte has come out in the blood. So indirectly, by looking at something in the blood, I am trying to find out what is happening in the bone marrow. Because see, if the bone marrow production will increase, common sense that the reticulocytes will be more in the blood. And if the bone marrow production will decrease, then common sense that the reticulocyte count will be low in the blood. So can I say this is a poor man's bone marrow? Why poor man? Because I am doing a simple 5 ml of blood sample I am taking. But by that blood sample, I am finding out indirectly what is happening happening in the marrow. देखो, bone marrow procedure करना तो would have been very, very painful. I have found an easier alternative. Why poor man? I think this is such a convenient man's bone marrow, I should call it. Just by taking a 5 ml blood sample, I am able to find out what is happening in the bone marrow. So they always say that finding out the RPI and doing all these is referred to as a poor man's bone marrow. They call it a poor man's bone marrow analysis, that is RPI. So what is reticulocyte production index? What is the formula? Reticulocyte production index is the corrected retic count divided by the maturation time. Now I know that I'm calculating reticulocyte production index, which is going to be a poor man's bone marrow. Corrected retic count formula, ma'am, we know. What is this maturation time? Going back to the same cycle again. Did you notice that once the reticulocyte comes out into the blood, it takes 1 or 2 days to become a mature cell, maturation time. So how much time am I saying? 1 or 2 days it takes to become a mature cell. So coming back, that maturation time depends on something. I'll give you a hint. That maturation time is going to depend on hematocrit. Hematocrit and maturation time are dependent on each other. What is the normal hematocrit? Normal hematocrit, I just told you, 45%. When the normal hematocrit is there, the normal maturation time is 1 day. As you will keep on decreasing the hematocrit from 45 to 35 to 25 to 15, your maturation time will keep on increasing by half a day. So it will become 1.5 days, then 2 days, then it can become 2.5 to 3 days. So that is how this maturation time increases. So as your hematocrit is going to go down, you will realize that your maturation index is going half day up. So repeating, all that you have to know is that when you have a normal hematocrit of 45%, your maturation time is going to be 1 day. And as your maturation time, as your hematocrit will decrease, your maturation time is going to increase. So they will give you some value of a corrected retic count, and on that corrected retic count, you will have to divide it by the maturation time, but they will not give you the maturation time. Instead of that maturation time, they will give you some element of a hematocrit over there. That is how you are going to analyze. So let me give you an example. They say that your corrected retic count has come out to be what? It has come out to be 2%. Okay, corrected. Abhi we did a formula na. Our corrected retic count had come out to be 2%. Beyond this, they say that the hematocrit of the patient has come out to be, say, 25. Hematocrit of the patient has come out to be 25. So what is the RPI? What will you do? Okay, corrected retic count to 2 hai, and I have to divide it by maturation time, but hematocrit is 25%. What is the maturation time? It is 2. What is RPI? RPI has come out to be 1. So if you know your formula, you are sorted. You don't need anything else. Even if I found out it was 1, to kya pata laga? Remember, when the RPI will come out to be more than 3 versus the RPI will come out to be less than 2. Okay, less than 2 and more than 3. So more than 3, this means my bone marrow is doing good work. It is a good response. My bone marrow is working well. That is why RPI is more than 3. When the RPI is less than 2, my bone marrow is not doing any work. I'm very sad. My bone marrow is hypoproliferative. It is not doing any work. So remember, when it is more than 3, there is increased bone marrow activity that I am seeing. When it is less than 2, this means there is a decreased bone marrow activity that I'm seeing. And if it is between the gray zone, if it is RPI coming somewhere between 2 and 3, then of course it's a straight face, means maybe my bone marrow is doing work, maybe it is not going to do work. So I assess as per the patient. Look at the symptomatology of the patient. Does he have mild anemia, severe anemia? Then you'll have to look at other factors. But simple, if it is more than 3, good work. Less than 2, bad work. Anywhere in between, I look at the patient and assess. So going forward, what are the 3-4 things that all of us are going to do, guys? First and foremost, we will find out, is the normal retic count given? Normal kitna hota hai? 0.5 to 2%. First, I will find out, okay, whatever is the retic count, let me calculate CRC. What is CRC? Retic count multiplied by hemoglobin upon hemoglobin. Once I get the CRC, what do I calculate next? I divide the CRC with the maturation time. I divide the CRC with the maturation time and get a reticulocyte production index. If it is more than 3, bone marrow doing good work. Less than 2, bone marrow doing bad work. We are done with all the reticulocyte related questions. One last thing left. You have used something like this round structure. They will give you this round structure and they will say, this is used somewhere in reticulocyte counting. What is it? Where is it used? What is the concept? So this is known as a disc. Can you see? A disc hai. So it's a Miller's disc method. What I call it, or what I prefer to call it, is the Miller's ocular disc. That is how I have learnt it. So shuru se na, learn the name like this only. Learn that ma'am is teaching us something called a Miller's ocular disc. Ocular disc will tell me that yeah, ocular matlab it is being used somewhere in the eyes. I can't put this disc in my eyes. I can't stick it in my eyes. So where am I going to stick it? I will stick it somewhere which sounds like the eyes. So what in the microscope sounds like the eyes? This microscope you guys have done in your general microbiology, the parts of a microscope. Jaldi se batao, what is going to sound like the eyes? You have these lenses over here. These lenses are known as eyepiece. These lenses are referred to as eyepiece. So can I now take, and these are lenses, na? These are nothing but lenses. So I am going to stick that disc, whatever disc I am talking about over here, whatever disc we are talking about over here means there is going to be a large box and then there's going to be a small box. So that disc I'm going to put it up over here. And then I will count the reticulocytes. So please note that in the big box over here, you will count the reticulocyte, and in the small box over here, you will count all the other red blood cells. That is how you will get the reticulocyte count. So you just have to know there is something called a Miller's ocular disc. Do ही questions आएंगे, 2 questions only. One question, let me write it. Question number 1, what is it used for? It is used for reticulocyte counting. Question number 2, which part of the microscope do you attach it with? So my common sense tells me ocular means eyes. I can't stick it onto my eyes. I can stick it onto the microscope eyes. So I'm going to put it on the eyepiece lens, and that finishes off your story of the reticulocyte. So reticulocytes are done. What are you moving on to next? I have discussed everything about reticulocyte. It became mature. What has it become? A red blood cell. So what